Hey guys, today we're going to have a look at the perimeter and area of composite shapes. So for this lesson, you're going to need to remember your formulas for the circumference of a circle, whether you're given the radius or the diameter, and the area of a circle, area of a rectangle, area of a triangle, and just remember that the perimeter of any shape is the sum of all its outer sides, or edges. Composite shapes we've seen before. Those are those abnormal shapes that don't really have a name, but might be made up of shapes that you do recognize and have formulas for. Here's an example. Now, technically, this shape is a pentagon because it has 5 sides, but it's not a regular pentagon, and I don't have any formulas for pentagons anyways. So I'm going to try and split this shape down into 2 simple shapes that I do have formulas for. I split this down into a triangle, which I've labeled A, and a rectangle, which I've labeled B. That way, if I'm trying to find the area of the full composite shape, I can just work out the area of A and add that to the area of B. Notice how I've already set up a formula here for the area of the full composite shape. So area A plus area B. Now area A, that's a triangle, so I'll just substitute its formula in, base times height divided by 2. And area B is a rectangle, so I'll substitute that formula in, length times width. Now I can't calculate anything if I don't have any values for my formula, so let me give you some values for the shape here. Now I can clearly see that the base of triangle A is 8, and its height is 6, while the length of B is 10, and its width is 5. So I'll go ahead and substitute those values into my formula. Now that I've got some numbers in my formula, I can do some calculating. 8 times 6 is 48, 10 times 5 is 50, so I've got 48 over 2 plus 50. 48 over 2, that's 24, so this is 24 plus 50, which is 74. Now remember, we're working out an area, which is a 2-dimensional measure. It's all the space that fills the inside of the shape. So that's why I'm measuring in centimeters squared. Squarea area, remember the rule. Now to find the perimeter of composite shapes, I probably shouldn't break this apart because I don't want to accidentally add up these sides. They're not outer edges of the shape because before I split them apart, A and B were stuck together along this side. And we're only trying to add the outer sides. So let's put this back together. So adding the outer sides, I've got 5 centimeters, 10 centimeters. Uh-oh, I need to work out what this length is before I can work out the perimeter. Remember, this was a rectangle before, so the opposite side, which is 5 centimeters, should be equal to this side. Now I can work out the perimeter. 5 plus 10 plus 5 plus 8 plus 6. And that works out to be 34 centimeters. Now don't get this confused. This is a perimeter. We're measuring length around the outside of the shape. And that's a 1-dimensional measure. So it's not going to be in centimeters squared. It's just in centimeters. Now here we've got another shape, which is rounded. What rounded shape is this? Anytime you see a rounded shape, remember the only rounded shapes we know formulas for are circles. We can work out the areas of circles, we can work out the circumferences of circles. So is this maybe part of a circle? Yes, it is. I've split this apart now into the shape A, which is some part of a circle, and shape B, which is a square that was filling in that space that was missing from the circle. Can you figure out what fraction of a circle this is? I'll give you a hint. That's a 90-degree angle there out of 360 degrees. What fraction is 90 degrees out of 360 degrees? It's a quarter, which means that a quarter of my circle is missing, so I still have 3/4 of my circle there. Now, how did I know that B was a square? It fit perfectly into that space that was missing for the quarter of the circle, which means that these 2 sides are equal. Now, how do we know these 2 sides are equal? Because they must be equal to these 2 sides. And what do we call these 2 sides? The length that goes from the center of the circle out to the side. No matter what direction that length is, that's the radius. So this is a radius and this is a radius. So the radiuses are equal to the sides of the squares as well. Right, so let's start writing our formula then. The composite shape is 3/4 of a circle and a square. So the area of the composite shape is going to be 3/4 of the area of a circle plus the area of a square. I know the area of a circle is pi r squared, so that's 3/4 of that. And the area of a square is length times width, so I'm going to add that on as well. Right, once again, we need some values if we're going to work out this area, so let me give you some values for the shape. Here I've labeled up here that this is 3 centimeters. We have already clarified that this must be a square because it fit perfectly inside this 3/4 of a circle, where this is the same length as this and this and this. So I know that my square has got all sides of 3 centimeters. And we also know that the radius of the circle must be 3 centimeters or it wouldn't have fit so perfectly. So we can substitute the 3 centimeters in here for the radius as well as for the length and the width. Right, so there I've substituted the 3 in for the radius, and I've just gone ahead and put the pi r squared multiplied by the 3 at the top of this fraction. And I've substituted the 3 in for the length and the width, so 3 times 3. So let's start actually calculating that. 3 squared is 9, 3 times 3 is 9, so this is going to be 3 times 9 pi plus 9. 3 times 9 is 27, so that's 27 pi over 4 plus 9. And now this is an exact answer right now. As soon as I put pi in my calculator and I start calculating, I'm going to get a very long, non-terminating decimal value, which is why I've left it like this for so long. But I think it's time to calculate now. That's going to be approximately 30.2057541, and it goes on forever. I wouldn't usually write out all these digits. I would just go ahead and round directly to 3 significant figures. So 3 significant figures, the 3 highest positions, 3, 0, and 2 with a 0 after it is not going to change. That's 30.2. And again, remember this is an area, so we're working in squared units. That's 30 centimeters squared. To work out the perimeter of the shape, remember we don't want to break it apart because we don't want to add in these extra side lengths because they are not outer side lengths of the shape. So let's put that back together. The sum of all the outer sides is going to be 2 straight sides. That's these ones here, which are 3 centimeters and 3 centimeters, plus the 3/4 of the circumference of the circle. So that's this red arc that I've drawn the whole way around there. Right, the 2 straight sides, as we've got labeled here, are 3 centimeters and 3 centimeters, and the circumference of the circle is 2 pi r. Right, so I'll substitute in the lengths 3, 3, and the radius of the circle, remember, it was the same as that length because it's this length from the center out to the side equal to the 3 that we've got up there. So we'll substitute that in. So I've got 3 plus 3/4 of 2 times pi times 3. So simplifying this, this is obviously going to be 6, and 2 times pi times 3 is going to be 6 pi. Now I've just gone ahead and put my 6 pi up at the top of this fraction. I've done 3 times 6 pi over 4, and here I've got my 6 out front. Now simplifying that again, 3 times 6 is 18, so that's going to be 6 plus 18 over 4 pi. And still trying to work with this exact until the very end so I don't make any rounding mistakes. 18 divided by 4 is 4.5. So this is 6 plus 4.5 pi. That is still an exact answer. I haven't rounded yet. But now I need to do my calculating with pi. I'm going to get a long irrational answer. So it's approximately 20 point something. Now I wouldn't usually write out all these digits. I would just go ahead and round to 3 significant figures just to show you what those 3 significant figures would be. 2, 0 is significant because it's between 2 non-zero numbers. So 2, 0, 1, and with 3 after it does not change that 1. That 1 will stay the same. That's going to be approximately 20.1 centimeters. Now this is a perimeter. It's not a 2-dimensional measure. It's just a sum of 1-dimensional lengths around the shape. So it's measured in centimeters, not centimeters squared. Now, how do we find the area of composite shapes? This is something that you might want to write down. First, work out what shapes make up the composite shape. That's going to help you figure out what formulas you're going to need to use. Then break the composite shape down into these parts. Then work out the area of each of these parts and add those areas together. Now, if possible, to avoid rounding errors, try to work out the total area in a single calculation. Don't forget, when you're working out an area, your units of measure will be squared units. So squared centimeters, squared millimeters, squared meters, and so on. How do we work out the perimeter of composite shapes? Again, you're going to write these steps down. First, work out what shapes make up the composite shape. Now, if you break the composite shape down into those different parts, do not add the sides that would be touching other parts of the composite shape, because those would not be outer sides. So work out the length of each of the outer sides of the composite shape, and then add those lengths together. Now, remember, let's not get this confused with areas. Perimeters are not measured in squared units. So here are some examples for you. You need to figure out what these shapes are before you could work out the perimeters or areas of them. What's this first shape? It's a rounded shape, so we should be thinking of circles. Is it part of a circle? Yes, that's a semicircle, or half of a circle. What about this next shape? It's also got a rounded part on it, and it's got some straight parts on it. Is it part of a circle? And then what's the other part of it? By pulling it apart like this, you can clearly see that that is a quarter of a circle, because that's a 90-degree angle, and a rectangle. This next shape is interesting. You can see that it has got some rounded edges on it, but it's not a full circle. It's part of a circle, and then there's a different size part of a circle there. If I draw this line in, you'll see that it was a full semicircle, just like the first one, but it's got something missing here. It's missing a smaller semicircle. And this last shape here is an interesting one. We could take little bits of circles and little bits of rectangles and triangles and put them together and make any shape we like. But what shape is this one? As you can see here, I've got the same shape as I've got over there, a quarter of a circle, and here I've got a rectangle, and there I've got another rectangle. So that's a quarter circle and two different rectangles. So let's try and work out the areas of these shapes. For a semicircle, let's set up the formula. That would be half of a circle. So that's pi r squared divided by 2. Here, this is a quarter circle and a rectangle, so let's work out the formula for this. A quarter of a circle would be pi r squared divided by 4, and a rectangle's length times width, so we'll add that together. Pi r squared over 4 plus length times width. This next one is an interesting one, especially when you compare the area formula for it to the perimeter formula for it. But this here, as we've written here, is a semicircle with a semicircle missing from it. So a big semicircle minus a smaller semicircle. So I've written that as pi r squared, where I'm looking at the big radius, divided by 2, minus pi r squared, where I'm using the smaller radius, divided by 2. Let me show you that on my diagram. This would be the big radius from the center of the circle all the way to the outside of the big semicircle. And this would be my small radius from the center of the circle just to the outside of this inner circle. Right, this next shape here, it's a quarter circle and two rectangles. Well, if we knew this formula, this shouldn't be too difficult. It would be a quarter circle, so pi r squared divided by 4, plus a rectangle, length times width, and another rectangle, length times width. But I've used special notation here to show you what my lengths and widths are. With this little a down at the bottom here, this is length of A. And this W with a A down at the bottom here, that's the width of A. And here I've got L with a B down at the bottom, that's the length of B. And W with a little b at the bottom is the width of B. Now, the perimeter formulas for these shapes is slightly different for the areas. With the areas, we work out the area of the shapes that we've broken them down into and we add them together. With the perimeters, remember, we're only adding the outer sides, and we are always adding the outer sides, never subtracting. So for the semicircle, it is half of a circle, but it also has this outer side, which is a straight line. What do we call that line that goes from one side of the circle all the way through the center across to the other side? That's our diameter. So I'm going to use the formula pi times diameter for the circumference of a circle and divide that by 2 because it's only half of the circle. And I'm going to add diameter because that's the straight length side. This next one's a quarter circle, so I'm going to find the circumference of a quarter of a circle, and I'm adding that to this straight edge here, that straight edge there, and this big long straight edge here. So I've worked that out as 2 pi r, that's the circumference of a full circle, divided by 4 because it's only a quarter of a circle, plus I've got r, which is one of the side lengths, so I've done this part of the curved circle side, this radius, plus 2 lengths of the rectangle. That's this top length of the rectangle and this bottom length of the rectangle, and 1 width, which is this side here. Not 2 widths because the other width is on this side, and I don't want to add that side in because it's not part of the outer edges of the shape. Right? Next shape here, the semicircle with a semicircle missing. Be careful, remember what I said before. Perimeter is adding all outer sides. So even though there's a semicircle missing here, we're still adding all of the sides. So I'm going to add this big semicircular circumference. I'm going to add this little line here. I'm going to add this semicircular circumference, and I'm going to add that side there. Everything is adding it, nothing is minused. Right? So I'm going to go ahead and set up that formula. For the circumference of a circle, I've used pi times diameter, and again I used a big D for the full diameter, the big diameter, dividing that by 2 because it's only half of a circle. And then for this smaller curved side, that's going to be also half of the circumference being pi times diameter, and this is half of it, so I've divided by 2. And then these two sides here, I got a little creative with how to work those out. I said that was going to be the big diameter minus the small diameter, because it would be the full length here minus this bit that I'm missing in the middle, and that would give me both of those sides that are left over. Okay, that's the big diameter, so that's the diameter that I'm going to use for the first circumference, and as well as this diameter, and that's the small diameter, which I'm going to use for the smaller circumference and for this value here. See how the big D, if I take away the little d, leaves me with these two sides left over. Finally, onto our quarter circle and 2 rectangles with that strange notation with the little lowercase a's and b's. The perimeter of this shape is going to be a quarter of a circumference, so I've done 2 pi r divided by 4 for this curved bit of the side there. Plus I've got 2 length a's, so that's this length a and this length a. And I've got 1 width a, which is up here. Not 2 of them because the other width a is down here, and that's cutting through the shape. It's not around the outside of the shape. Then I've got 2 length b's, which is this length here and this length down here, and 1 width b, which is over here. Okay, so let's see if we can get some practice in. I don't know if maybe you need to go back and take some notes about what we just done, but I'm giving you some examples now where they're the shapes that we've seen before, and I want you to work out both the perimeter and area of the shapes. So feel free to go back and look at those formulas again, or hit pause now to see if you can work this out for yourself. I hope you hit pause and had a chance to work those out for yourself. Here's the perimeter. Now that's the exact value of the perimeter. When I work that out on my calculator, this is my rounded answer, 18.0, and there must have been something after that 0. This is rounded to 3 significant figures. Here comes the area. Now that's the exact value for the area. When I worked out the area and rounded to 3 significant figures, I got this. I hope you used the correct units of measure. The perimeter is measured in centimeters because my shape is measured in centimeters, my length, and the area is measured in centimeters squared because it's a 2-dimensional measure. Here's another example for you. Again, hit pause if you need a chance to work this out, and go back if you need to see the formulas again. I hope you've hit pause and worked this out for yourself already. Don't look at the answers until you've given it a try for yourself. Here comes the perimeter. Now again, that's the exact perimeter, and rounded to 3 significant figures, the perimeter would be approximately 24.9 centimeters. I hope you've worked out your area already as well. Here comes the area. That's the exact area. And when I work it out and round to 3 significant figures, I get this. Again, my perimeter is in centimeters. It's a 1-dimensional measure. And my area is in centimeters squared, 2-dimensional measure. Here's our third example. Again, you may want to have to look at the formulas. This one was a bit tricky. Work out your perimeter and area of this shape. Hit pause so that you have some time to work that out for yourself. If you need a hint, this 15 up here, that's the full diameter across. I didn't give you the small diameter in between, but I gave you these two sides, which are 2. Which means if the whole thing is 15, and I'm taking away 2 from that, and I'm taking away another 2 from that, this length in here, the smaller diameter, would be 11 centimeters. If that's helped you, maybe you need to take another pause and work it out. Okay, let's take up the perimeter. That's the exact perimeter. And working it out to 3 significant figures gives me 44.8 centimeters. The area, the exact area is 13 pi. And if I work that out to 3 significant figures, it's approximately 40.8 centimeters squared. Last example now. Again, hit pause to work this out for yourself. If you need any help, I'll give you a hint in a second, but try for yourself first. Right, if you're working out the perimeter of this, your hint is that you need to add up all of the sides around the shape, including this side here, which I haven't labeled for you, but you know this is part of a rectangle, so you know what this length is. You should know what this length is because, again, it's part of a rectangle. And this length here, we know is part of a circle. It's a 90-degree angle there, so that's a quarter of a circle. And the measurement we know for this circle is the radius is equal to, it's the same on both sides, the radius here is equal to 3. So hit pause again if you need time. Let's work out the perimeter and area of the shape. Okay, here comes the perimeter. That's the exact perimeter. Rounded to 3 significant figures, it would be this, 32.7 centimeters. And the area, the exact area, 2.25 pi plus 33. And rounding to 3 significant figures, approximately 40.1 centimeters squared. Okay? If you had any problems with any of these, or if you noticed I put any mistakes in there, of course that's to see if you're making sure you're paying attention, please let me know. Otherwise, well done.